Now, you have 4 graphs before you. If I am going to ask you, which of these graphs represent a function? So the question is, which of these graphs represent functions? So you should say this is not a complete question. So which of these graphs represent a function? So this is not a complete question, because if I ask you which of these graphs represent a function, I should also mention the domain and codomain in which I need to check whether this is a function or not. So let us say that if I ask you to check whether these are functions defined from real numbers to real numbers. So if I ask you which of these relations or which of these graphs represent functions defined on real numbers to real numbers, the answer is none, because none of them pass the vertical line test over the whole set of real numbers or the whole domain of real numbers. None of them satisfy the VLT, because if you take this, so if you draw a vertical line beyond -2 and after 2, they are not cutting the graph. Hence, this is not a function on the domain of real numbers. Codomain is right now not very important. Here also, if you draw vertical lines beyond 1 and -1, it's not intersecting. Here also, if you draw lines beyond 2 and -2, 0 and 2, the vertical lines are not intersecting the graph. Here also the same position. So from real numbers to real numbers, none of them are functions. Now, so let us take the first diagram. So I want you to check whether this graph is a function on the domain -2 to 2. On the domain -2 to 2 to some range. I'm not really concerned about the codomain. So within this domain, is it a function? The answer is yes, because this curve passes the vertical line test. That is, everywhere at any point between -2 and 2, wherever you draw a vertical line, the vertical line is intersecting the curve at only one point. So this represents a function on the domain -2 to 2. Now let us take this. So does this represent a function in the domain -2 to 2 to some range R, some codomain? Codomain is not important here. So between -2 to 2, does it represent a function? Yes, because this graph also passes the vertical line test. Corresponding to every x, you have only one y. Corresponding to this x, you have only one y. Corresponding to this x, you have only one y. So on. Corresponding to every value of x, you have a single value of y on this domain. Hence, this is a function on -2 to 2. Now let us go to this. Is this a function on the domain -1 to 1 to some codomain R? The answer is no, because if you draw a vertical line, the vertical line is cutting the graph at 2 points. So to make this a function, what I can do is, I have already restricted the domain, because if the domain is real numbers, none of these are functions. So within -2 to 2 restricted domain, the first one is a function and the fourth one is a function. And for the first and fourth, the codomain need not be restricted. Now for this, on the domain -1 to 1, this is not a function, because vertical line is cutting the curve once above x-axis and the next below x-axis. Now to make this a function, what can I do? So what I can do is, I can restrict the codomain also. So I say that this function is defined from -1 to 1 to the set 0 to 1. The codomain is only 0 to 1. So if the codomain is 0 to 1, you won't be getting these points. You won't be getting these points because the values of y are always positive within this codomain. So this part of the graph will disappear within this restricted domain and within this restricted codomain. Now this graph is passing the vertical line test. It is within this domain and this codomain. This graph represents a function. It is not necessary that you have to go to this particular codomain. You can also go something like this, -1 to 1 to -1, 0. In this domain and codomain, the above graph will be cancelled now. You have only one below graph, that is also a function. So within this domain and this codomain also, you have a function. Next, it's not necessary that this is the restriction of the domain. Even if you restrict the domain to 0 to 1 to 0 to 1. So you have domain restricted to 0 to 1 and codomain restricted to 0 to 1. You will have only this part of the curve. Here also it is a function. So what we can do is, by restriction of domain and codomain, we can get some part of the curve where it is a function. So if you are asked to restrict the domain where it is a function, I hope you understand what to do. You see the graph and identify the part where the VLT is getting satisfied, and that should be the corresponding restriction. Next, if you go to this curve, if you restrict the domain to 0 to 2, the outward part has been eliminated. So within this domain also, you can see that this curve is not satisfying the vertical line test, because if you draw a vertical line here, it's cutting at 2 points. If you draw a vertical line here, it's cutting the graph at 4 points, so on. So this is between 0 to 2 also, this is not a function, because I have not restricted the codomain. So within 0 to 2, if you want to make this a function, what should be the codomain restriction? If I make the codomain to 1, 2, if I restrict the codomain to 1, 2, so I'll have only this part of the curve, right? Because the codomain is in between 1 and 2. The y values are in between 1 and 2. So all this graph will get vanished. So within this domain and within this codomain, the graph represents a function. So this part will be a function, this graph will be a function within the domain 0 to 2 and codomain 1 to 2. This is not the only thing. You can have other restrictions of domain and codomain. This restriction is not unique. So you can have different ways in which you can restrict your domain and codomain to make it a function. So I hope you understand what VLT is, vertical line test is, and how to restrict the domain and codomain so that a relation becomes a function. Thank you.